Yeah, good morning. Is it audible, ma? Yes, respond. Am I audible? Hello. Okay. Uh, so in the fourth unit, one topic is there. Okay, that is a last topic. So we'll see that. Okay, in the code generation. Uh, so this is a last phase of the compiler. So already introduction part completed. Okay, so the main functions of the code generator are instruction selection, register allocation and assignment, instruction ordering. So these are the three main functionalities of code generator. First, instruction selection. So it is going to choose appropriate to target machine instructions to implement the intermediate representation statements, whatever the intermediate representation statement, whether it is a three address code or whatever it is. So target appropriate to target machine instructions selected in the instruction selection for implementing that are three address code statements, whatever. So that is nothing but instruction selection. Next functionality is register allocation and assignment. So here deciding what type of values to keep in which registers. Okay, then value some variable or constant, whatever some value. So which register is suitable to store that type of value. So that will be decided in register allocation and assignment. Okay, first two registers are allocated. Set of general purpose registers are going to be there. Then registers are allocated. Then after allocating, some value can be something can be assigned to that register. That is nothing but register assignment, register allocation and register assignment. This is a second task, second functionality of code generator. So third one is a instruction ordering. So order is important. So to get the benefit or to make efficient to target code, or if we are to utilize a lesser space, that means time taken to execute, you want to take less, that means to save the memory, to save the time, then ordering, that is important. So in which we arrange the order, then definitely it will save the time. So that means within the time that whatever code will be generated, that execution, everything is fast. So that is ordering, order the instructions. Okay, that is a third functionality. uh, Next, these are the issues, design issues. Okay, this is a important one of the important topic. Design issues of code generator. So input to the code generator. So which kind of input is providing for the code generator? So that is a issue. So here different types of forms of inputs can be given. So the appropriate the input is given, then efficient target code can be generated. So here that is a issue. So what are the different kind of inputs available for providing to the code generator? That is a issue. Target program. So different kind of target. So that means output can be generated from the code generator. That is also issue. Then memory management. So resource allocation, assignment, that is nothing but a memory management. So instruction selection, selecting the machine instructions for what, for implementing that in intermediate representations, that is the instruction selection. Next, so register allocation, allocating registers, general purpose registers. Then choice of evolution order, that order of the instructions, execution order. Then approaches to code generator. So these all are the issues in the last class we have completed. So this is explanation. With evaluation order. Okay, for this statement, three letters code will be this one. This is a three letters code for corresponding this statement. Okay, here, so this is assembly target code generation for this. Then this one also, uh, after reordering, these are the instructions T1, T2, T3, T4. These many instructions. For these instructions, this one is a target code, that is code generation, code generated, that is assembly code. Okay, so these are the instructions. First to T1 executed, next to T2 executed, next to T3 executed, next to T4 executed. Okay, but if we arrange, so A plus B, C plus D, okay, not depending on each other. Okay, so these two are the independent, not depending. If dependence is there in that, then we should follow that order. So we don't change the order. Okay, if it is a independent instructions, so we can change the order. Here these are the independent, so not depending. So first to T2 executed, the next to T3 execution, T1 execution, T4 execution. So reordering, so order change for this three address code. So with this three address code, we'll get this as a target output, the assembly code. So now you can observe. So this one is easier, this one is easier. So obviously this one is easier. So it takes less space, then execution and time is less, everything is less. Okay, so evolution order, even though if you execute this also will get the output, this also will get the output, but it takes more space, much time, but takes less space, less time. So that is a evolution order. Okay, then target machine. So for the instruction, for every instruction, so there will be a target machine opcodes. So OP opcode, then source and destination. Already we have seen the target machine addressing modes, different kind of addressing modes, absolute, register, indirect, indexed. So these are the different kind of addressing modes. Every instruction have some cost after executing. That means for every instruction there will be a cost. So what is if registers involved, then cost is less than register and memory used, memory indexing or locations used, then cost is more for that instruction. So already we have seen this. So instruction selection, so select the appropriate instruction. You can see A equal to A plus 1. This is an increment operation. Okay, so for this increment, so these many instructions required. So these many 3 instructions required, then cost is 6 for this. Okay, here we have one instruction, that is a INC. INC automatically a value can be incremented by 1. Okay, here only one instruction, here 3 instructions. In this case 3 instruction, in this case only one instruction, cost is 2. Okay, so select the best instruction. Okay, which instruction is going to give cost less, then select that kind of instruction. Okay, this is an instruction selection. Then addressing modes, already we completed this runtime storage management. So static allocation, heap allocation, stock allocation. Okay, register allocation and assignment. Here in memory is nothing but some memory that is near to that processor. Then accessing everything is fast. So if the data stored in the register, that accessing where no need to go for the secondary memory. So directly that processor or whatever takes that information or values from the register. So accessing is fast compared to other kind of memories. Okay, so here's a different kind of registers like stack pointer, base, in different kind of general purpose registers. So I think you might have studied in the computer organization. Okay, so your main thing is a register allocation and register assignment. So at each program point, select a set of values to reside in registers. So here select we have to select the values. So which values are going to be reside in registers. So that is nothing but register allocation. The register assignment. So pick a specific register for each value. Uh, then based on the configuration, so picking up a specific register, so that is nothing but register assignment for a value. Something is added to that register, that is nothing but register assignment. So assigning that register. Okay. Uh, here for the register allocation, some techniques are there. This one is three techniques. One is a global register allocation. Global register allocation. This is one method for register allocation and assignment. So in this, in the code generation algorithm, registers were used to hold values of a single basic block. So basic block already we have discussed. If any program is any algorithm any given, so first of all we have to divide it into basic blocks. Okay. Some statement which are there in one block, those all are the similar kind of statements. Like that, divide that entire program into basic blocks, then draw the data flow diagram for that. So connections are going to be there that shows the information from which block to which block flowing. So already you have seen that is a data flow analysis. Okay, so first of all, these registers were used to hold values of a single basic block. So at the end of a block, store instructions were needed in order to store the live values in memory. So live variable analysis, we have seen in the basic block only the data flow analysis. So reaching definition, live variable analysis, so dead code elimination, so different kind of terminals we have seen in the data flow analysis. Okay, so here also same thing. If a block is there, then some input is given to the block, and some information can be sent from that block, that is a output. Some input and output are going to be there for a basic block. Then that depends on the live variables. So which information is going out from that block, that is nothing but a live information, live variables. Okay, your live variables are the ones which are going to be used in subsequent blocks. So for example, if one block is there, b1 block, so some variables can be given to the other basic blocks. So those kind of blocks is called live variables. So that means a variable used in one block, so same variable is used in the subsequent blocks. That type of variable is called live variable. Okay, live variable. So here global register allocation and local register allocation. So local register allocation, global register allocation. Local register allocation means if a basic block is there, then how many registers are required for executing that instruction. So that is nothing but a local. Global means in throughout the data flow analysis in all the blocks. So how many basic blocks are going to be there? So we have to consider all the basic blocks. Then how many registers are required for that entire program? We have to analyze. That is nothing but a global register allocation. So first local LRA means local register allocation was slightly modified for registers in order to hold frequently used variables and keep these registers consistent across block boundaries. Okay, some local variables, same concept, but so those can be modified for the registers to hold the frequently used variables. So which variables are frequently used? So for them, allocate this local register. That is not allocate register, that is called local register allocation, and they keep these registers consistent across block boundaries. So that is nothing but a globally. So that is a global register allocation. So programs will spend most of their time in inner loops. So okay, if you take one program, if you consider one program, loops, if loops are there, then most of the time that flow of control within the loops only. So natural approach is that to keep a frequently used values in fixed registers throughout the loop. So here we have to allocate some registers which that registers fixed registers, so allocated for a variable which is used in inner loops. Okay, that is, so that means we have to fix some registers for the variables which are used in the inside loop. Okay, that is, but number of registers are fixed. So if a program have loops, some conditional statements, so in that case fix the registers. So but most of the registers are fixed. So programs are written as if there are only two kinds of memory. So generally main memory and the secondary memory. So programmer is responsible for moving data from what secondary memory to primary memory, or from file. So IO that related. So hardware is responsible for moving data between the memory and cache. So cache memory. So compiler is responsible for moving data between memory and registers. So now compiler. So generally, compiler, whatever the type of compiler. So if we use, then that compiler is responsible for moving whatever the data between the memory and registers only. So why registers? For fast accessing, for fast execution, the registers used. So compiler is going to move the data between the memory and registers. Okay, so first one is a global register allocation. That is one type of technique. So next, usage count. Usage count. So here, if a variable x, for example, a variable x is in register, then we can say that we have saved one cost. Okay, one variable is there. So that is in register, some one register. Then we can say that we have saved cost to 1. So if a variable x is defined somewhere outside the loop, then for every usage of x in block we will save one cost. If one variable is used, then cost is 1. If variable is defined outside a loop, then that is used in that block, then we can save cost 1. So for a variable x computed in block, if it is live on exit from block, then count a saving of 2. So saving of 2, since it is not necessary to store it at the end of the block. Okay, so we will see one example, you can understand this. So this is a formula. For example, there are some set of basic blocks. Okay, so here we have to find out what is a usage of a variable. So this is a sigma. So whatever the blocks, we have to consider each and every block. Use of x comma b, use of x comma b plus 2 into live of x comma b. So b is any block, then x is a variable. If that x variable is used in that block, so we have to consider the cost plus 2 into live. If the variable is live, then cost is 1. So we have to see where use of x comma b is number of times x is used in b. So how many number of times x used variable? Already we have seen the terminology used variable. So if the variable how many times that x is used in that block, so we have to prior to any definition of x, prior to any definition of x, that we have to consider. Okay, that is the use of x comma b. Next to live of x comma b, this is one if x is live on exit. If x is live on exit from b and is assigned a value in b, otherwise 0. When a live of x comma b is 1 if x is alive on exit from b and is assigned a value in b. If it is assigned a value in b and if it is alive, then that live of x comma b is 1, otherwise 0. Okay, so we have to consider this formulas. So this is one data flow graph. This is a basic block b1, b2, b3, b4. Okay, so this is a input. Okay, this is a input, entered. Then this is one is exit, this one is entering. Okay, these are the live variables. So a, c, d, f or live variables from this block. Then a, c, d, e or the live variables from this block. Then next c, d, e, f or the live variables from this block, and same c, d, e, f also live variables from this block. Then e, f is a live variable from this block. Then b, c, d, e, f or the live variables from this block on the exit. So a, b, c, d, e or live on the exit of b4. Okay, this is a graph given. So here we have to find out the usage count for each and every variable. So these are the variable, how many, what are the variables? A, b, c, d, e, f, these are the variables. Then what are the usages, usage of variable in the data, in this graph, in the data flow analysis. We have to find out that first. Okay, so first a, so a is a variable in b1, in b2, in b3, in b4, summation of all. So we'll get that usage count of a. Okay, so first what is the formula? Use of x comma b, use of x comma b. So a is used in this a. Okay, a used, but assigned and used. So there should not be assign statement. So assign, this is nothing but assignment statement. This is a using statement. So in case of used variable or right hand side we have to see, but that should not be assigned in the block. So before using one assignment statement some there, so that usage is 0. So usage 0 in b1. So next what, live 2 into live of x comma b. So on the exit a is live, then assignment should be there, and on the exit it is live. So cost is 1. So 2 into 1, 2. So 0 plus 2. Okay, in b1 block. Then next in b2. Okay, so first use of x comma b. So used variable, no assignment. Okay, cost is 1. Yeah, cost is 1. So next live. So a is not live on exit of b2. So a not there, but here on b1 a is there. A is a live variable on the exit, but on b2 on, that is not live. So that's why 0 into 2 0. So that's why 1 plus 0. So next b3 we have to consider. In b3 used. So a used. Okay, so a used. So 1. Next live variable, live. So a is not a live variable. Okay, so 0. 1 plus 0, b3. Next to b4. What is a used? 0. used 0. Then live, so we should not consider this one. There is no blocks, so we have to consider this one only, from B3 to B4, then B4 to B1. So don't consider this. Okay, so here it is not live on exit of B4. So what, 0 plus 0. So total cost 2 plus 1 plus 1. Total cost is 4. So that usage count A is 4. Okay, next to B. B. So 1, 2, 3. 3 using, but no assignment. If assignment is there, so we should not consider it as a used variable. So B is used how many times? 3 times. So 3. Okay. So next to B is a live variable. So here B not there. Here also B not there. So 0. Simply 3 plus 0. So next in B2, B used variable? No. Then is it live? No. Okay. So 0 plus 0. So next to B3, B is not used variable, and it is not a live variable. So 0 plus 0 in B3. So next in B4, so it is not used variable, but it is live. Live. So 2 into 1, 2. So 3 plus 2, 5. Okay, that is usage count for B. So next to usage count for C we have to calculate, and usage count for D we have to calculate. Then usage count for E we have to calculate. Then usage count for F. Why? Because so A, B, C, D, E, F are the variables in this that data flow. Okay, so here how many registers are required for, so which are the frequent variables used? So based on the usage count we can say, so for that we have to fix the registers. Okay, so here which one have usage count is more? B have more, 5, then E 5. So 5 times B used and E used in that. So why? Because the usage count is 5. Yeah, usage count is 5. So fix the registers for this. So next which one? 5 B E. Next to A F. F. So usage count is 4. So for this also fix the registers, but B and E have usage count more. So fix the registers. Don't allocate that register to other one. So fix the registers for B and E. So whatever you want to allocate a register for B, or you want to register allocate, that means these two are in the same category, same priority. That means register, allocate one register for B and allocate register for E. Okay, so next to A, D, F are same. Why? Because usage count is 4, and here also usage count is 4, and usage count is 4. Okay, so fix a register for this. So that means, for example, the register 0. Register 0, in register 0 we can allocate for B or E, and register 1 for A or D or F. Then register 3, then which one for C. So like that. So this is a register allocation and assignment. So usage count based on the usage of a variable in the data flow. So we have to allocate the registers. That is this is one of the technique in the register allocation and assignment. Okay, this is one another example. So like that. So here 6 is usage count for B, then for D. Okay, these are the same category. So fix the registers for this. The next to 4, the next to 3. So 3 category registers are required for this. So based on usage count we can allocate. So this is another example. Okay, so So usage count is one type. The next to register assignment for outer loops. Register assignment for outer loops. If an outer loop L1 contains an inner loop L2, so here are two loops. One is a inner loop, another one is a outer loop. So L1 is a outer loop, L2 is a inner loop. So the names allocated registers in L2 did not be allocated registers in L1 minus L2. So here some registers can be allocated for L2. So L2 is a inner. So inner loop. So one register is allocated in L2. So whatever the register allocated in L2, that should not be allocated in which region? L1 minus L2 region. Okay, that register is fixed for L2. So the register should not be allocated in this region L1 minus L2. That is, however, if a name X is allocated a register in loop L1 but not in L2, we must store X on entrance to L2. Okay, and load X on exit from L2. So even name that X allocated register in loop L1 but not in L2. Okay, so we must store that X on entrance to L2. Okay, and load X on exit from L2. So store entrance to L2 and load exit from L2. Okay, so similarly, if we choose to allocate X a register in L2, so in this case, so previously in L2, but not in L1, so we must load X. So here first to store X, here load X on entrance to L2 and store X on exit from L2. So this it is opposite. Here first store X on entrance to L2, here load X on entrance to L2. Okay, so this is a register assignment for outer loops. The next one is a graph coloring. This is another mechanism, register allocation by graph coloring. So when a register is needed for computation, but all very available registers are in use. So for example, where one register is needed, that is required for computation, but all available registers are in use. The contents of one of the user register must be stored into memory location. So in this case, what we have to do? So we want to execute something, some registers are required to execute that, but registers all are allocated or all are in used. All registers are used. So in that case, what we have to do? So select one register. So whatever the content is there in that register, then move that content into memory location. That is nothing but spilled. Okay, so perform data flow liveness analysis over a context free that graph. Collect variable liveness info at every program point. So for this, what we have to do? So live variable analysis we have to perform in the data flow. Live variable, which are live variable. So previously how like that. So live variable analysis have to be done. So for every program bind. Then next build an interference graph. So each node represents a temporary. That means here we have to build one graph. So that is a what graph coloring. So first so graph we have to construct. So here each node represents a temporary variable. Each edge represents an interference between two temporaries. So they can't be assigned to the same register. So in the graph, nodes are going to be there, edges are going to be there. So nodes represents a temporary value, edge represents an interference between the two temporaries. So here we cannot assign one register to the same nodes. So one edge is going to connect with connect the two nodes. So one register should not be allocated for this type of nodes. So color the interference graph. So colors equal to registers. So we want to use as few colors as possible. So for a machine, with K registers decide whether the interference graph is K colorable. Okay, if yes, coloring gives a register assignment. If no, need to spill some temporaries to memory. So here, before allocating, if one register is allocated, then give a color to that register. Okay, if color is there, then that register already assigned. So if color is not there, then that is a free register we can assign. If all registers are colored, so in that case, what we have to do? Select one register, move the temporary that contained to memory. So that means spill some temporaries to memory. So like that, this is another approach for register allocation. By coloring the graph, we can identify which registers are free, which registers are used. Okay, so this one is a last with this entire subject completed. Code generation completed. So with this, all units, all phases covered. Okay. So any doubts you can ask me. I will forward all everything. So material. So already I have shared mid one. That means 2.5 units. So remaining I will share. You are interested, you can refer this material. Otherwise, you have tutorials, YouTube videos. You can, so many resources are available. You can utilize. But I will share this material. What you need to 3, 4, 5. So 3 units material I will share, and okay, this is a last week I think. So in the next week you are going to write the mid exam, something schedule is there. So today I will share the manual also. I have programs but not yet prepared the manual. So today definitely I will share to your CRs. So get that manual from your CR and write in the observation and record. So total 5 experiments. So write in the observation and record. Compulsory observation and record. Yes. So anything regarding this project? So already I have created the batches, but other sections pending. So after completing other section batch preparation, so at a time we are going to announce by allocating the guides. Yeah, this time actually in the for your senior, if you submit the abstract, based on that we'll allocate the guides. But this time, so just we allocate the guides. After guide allocation, we'll announce the batch details. Okay, so now I'm stopping. So tomorrow no class. Not tomorrow actually I have English duty. So syllabus completed. Okay. Uh, Tomorrow Wednesday no class. Thursday no class. So Friday also I will not be available. So if I available, I will inform. Okay, but you complete the writing this observation and record. I will share them that lab manual. Okay, tomorrow no class. Then Friday also no class. Yeah, respond for the attendance, ma.